This is the fifth video in our series of highly entertaining videos about classes and constructors and object-oriented programming. We have seen that every new video shows that there are some bugs in the previous videos and that there are some improvements. So this video I mentioned in the end of the fourth one, yeah, there is something more that can be improved. So before we go there, I'm going to just show to you how functions are behaving and how they interact with our classes. We will first create function that prints the statement, but some new way of printing. Better printing. And we will accept the argument of the function will be credit card account. We are going to call it D. And in this function, we will just print this is a better way to print. I will end this with new line. And then just regularly print the statement. The print statement. I'm going to have this just above my main function. And I will now delete so many objects. I will just create dog. There will be no cat. Only dog, poor chug. We will just add one transaction to our dog. $15.1. Okay, let's add two. And then better printing is called. Let's see how this code compiles. It compiles without any errors, and let's see how it executes. So, one constructor is called to create dog. When we have command cc account dog, the first constructor was called, and then a copy constructor was called to create another object D. Object D was created using copy constructor because this call to the function passes the argument dog, but then this line of code actually gets replaced with a line of code cc account dog equal of D, which calls copy constructor. Calling the copy constructor is not always fun, because we have seen copy constructor results in entire stack being copied. Now we may have many more elements. Now this one has only 2 elements, but if it had 2 million, we would wait a lot of time just for executing this function. One small change will result in big improvement to our code. By putting this ampersand, then the first line of the function will be replaced by cc account ampersand dog equals D equal of dog. And so actually it equals dog, and that means that we are asking the computer, dear computer, please don't create any new memory. Please just let me use the letter D as well as dog for that very same object. So by passing the object by reference, our code has improved. So if we compile now the new code and execute this new code, this was the old execution. It had copy constructor and two destructors. The new execution has no copy constructor and only single destructor for poor chug. The reason is, inside the function we did not create a new object. Passing by reference is used in this situation to save the time and the memory. We have seen before that passing by reference allows us to modify this object dog, but it's now good practice to inform everybody in our program who will be reading and maintaining our code what is the reason for using ampersand. So that's why we are using the word const. When I put the word const, it means I'm making the promise that I will not change the variable d. So variable d will not be changed, and the programmer of the main function can be rest assured that I will not be negligent with the variable dog. I will not be negligent. I will take it with the best and utmost care. My code will now result in a certain bug because it will not even compile. The reason is I am promising that I will not change my variable d. However, I am using print statement. Compiler does not trust me because compiler has observed that I'm using a method in my class. So although I did not obviously change the variable d, but maybe print statement has performed some changes. Let's look at print statement. Did I pass that? Yes, I did. Print statement. Print statement does not change. Print statement doesn't change balance. Print statement doesn't change CNAME. However, compiler had no way of seeing that. So now, the way to inform the compiler that print statement is a very safe function, we have to be very brave and put the word const in the declaration. So const at this place means, dear computer, I am promising that my method print statement will not touch any of the attributes. It will not touch balance, it will not move AHT, it will not touch the variable AHT, and it will not modify CNAME. I may only read those, so this method is called accessor. When I put the word const, my method is accessor, and I'm promising that I will only access the elements of the stack. My promise has to be put everywhere, so I put the promise in the declaration, and I put the promise in the implementation after the name of the function. Now the code will compile. And we have achieved our result, our goal. So, good programming technique, and if you are programming with some friends or if you are working in a company, you are going to be required. Every method that is not changing anything in the function must be const. So these are the rules of good behavior. So this is accessor. Get balance is accessor. So we are promising that by checking the balance we will not do anything else. So I'm now going to hunt my function, check balance, and signify that that is accessor. By not having the word const in the end of the declaration, the function is called mutator. The method is called mutator. That means whoever is using this method should be aware that the class will suffer, will change after this method. Add charge is a mutator. So then we also, it's a good programming, and actually this is mandatory, so I'm now resolving one bug. I was just lucky that my bug did not surface so far, but in copy constructor it is required to put const to prevent some future bugs. The same holds for copy assignment. This has to be done here and in copy assignment. Now I will clear all of this, compile again, and the code compiles. Const, the existence or non-existence of the words const, of the keyword const, does not change the binary. So this is just something that gives trouble to the programmers who try to and prevent some bugs. So because we promised that this is accessor, so compiler will tell us if we did something illegal. If in the accessor we try to modify some of the attributes, or if we called another mutator. Accessors are only allowed to call accessors. Mutators can call both mutators and accessors. So in the print statement, I cannot call add charge. So add charge is mutator. All constructors and all destructors are mutators. So now we will move on and create a new function that creates the function that returns one object. So cc account function with return. We will just call it FWR, function that returns. It will be the simplest one. It will not have any arguments. And FWR, so we don't forget for later, function with return. So what is my function going to do? I will create a dog, and inside my function so instead of specifying the name of the dog in the main function, I will just call dog equals FWR. And in the body of my function, I create an object of type D, d.cname equals poor chug, add charge, so we will add two charges of $15.1 and $15.2, and then we will return this D. Now this is another way to create dog, and now we will just print the statement. Dog print statement. We will now compile the code and execute this code to see what happens. So finally, when we print this, so there are many things that are going on. So the next 15 minutes, oh, this is going to be a long video. It was already 15 minutes, it's going to be another 15 minutes. The next 15 minutes will be about what is going on. Why is this function printing so much? So let's talk first about things that we do understand. Print statement prints account owner is poor Chug, the balance is $30.30, and we see all the transactions. However, in the course of executing this function, our code has run several assignments, constructors, and there is a destructor. Actually, it even did some optimization. So I'm now going to compile the code again, but with a flag. C++cc account. Output will be again the file A. We will specify that we want C++11, and I will also put another flag. No allied constructors. With this compiler flag, we will see even bigger printing. So we see copy constructor is called, copy assignment is called, and then 3 destructors. So it seems that there were some 3 objects created in the course of executing this method. And now we will learn why did that happen and how can we avoid this. Are some of those destructors and constructors unnecessary? So to get started, we will look at our memory diagrams. So before our function gets executed, let's first analyze the memory. After we create, at the start of the main function, we have the command, dear computer, please give me sufficient memory for 1 credit card account and let me call it dog. So the computer gives us the memory for 1 dog. And it will call the constructor that puts 0 for the balance, and address of the head of the transactions will be null pointer. Then we call the function. Once the function is called, we will draw the memory diagram of the function here. So we will type FWR to signify that this memory is created because of the function. Inside the function, we have the command ccaccountd. That means we ask, dear computer, please give me the memory for 1 credit card account and let me call it D. So that's why the constructor was called. Then we set the name to poor Chug. We added 2 charges of $15.1 and $15.2, so we created the stack. Now we will talk about what happens when the command return D is executed. And what happens now is that we run into some procedure that takes 5 steps. So the first step is, why it will take 5 steps? Because several things have to happen during the return statement. The content of this D has to go to our global variable dog. Not global, actually, the variable from the main function. Then function has to clean everything. This D has to be destroyed and memory returned to the program. So what happens is in C++ the following 5 steps occur. First step is creation of a temporary object. So one temporary object is created from the dog, so that way the function can be cleaned when this D is destroyed. So temporary object is created from D. So this D will be destroyed and the return value of the function will live in this temporary object for a short amount of time and before it's being transferred to the dog. Because technically our function in more general situation could have many more objects, could have a lot of variables, may have consumed a lot of resources, So the return value is stored in the temporary object while function deals with cleaning the memory. So that was step 1, creation of the temporary object, and now function is ready to clean the memory. So step 2 is destroy the local variables. At the moment there is only one local variable, that's d, so it's going to be destroyed, but our function could have had many of those. Third step is now assigning temporary object to dog. So now from temporary object we go to our variable dog in the main function, and that's where copy assignment is being used. When copy assignment is executed, the stack is again copied, and we have dog becomes the object that has name poor chug, has those two transactions. So copying is done. Now fourth step is destruction of the temporary object. Now we have to destroy temporary object, and fifth step is final cleaning of the function. Our function does not have very big cleaning because it did not have any arguments, but in the fifth step arguments would be destroyed. If our function had some arguments inside these brackets, those arguments will be destroyed in the fifth step. And the function is gone, and we end up with clean main function that has only one object, dog. So from function fwr, a lot of things happened, and we created, so I'm going now to repeat all those 5 steps again, and by looking at them again, I'm going to point out some inefficiencies and performance hits that occur because of these functions. So first we have main function, then the function fwr is called, it creates object dog, and when we enter to the return phase of the function, first is creation of temporary object. That results, so now the inefficiency is that the stack, very big stack, actually 2 is not a very big number, but if stack had millions of numbers, this step would take a lot of time to move this big stack to the new spot. Then step 2 is deleting the local variables. Step 3 is assignment, copy assignment, and in this copy assignment we are again seeing very long process of copying this entire stack. Actually, we should also not ignore step 4, that's potentially also difficult step, destruction. So temporary object has to be destroyed, and if the stack was long, we had to go element by element and destroy each of them. And then the last step was destruction of the arguments of the function. So C++ has found a way to improve and speed up the process. So by introducing the following idea. So the idea is we want to prevent some of unnecessary copies. So we are still going to have the same 5 steps, creation of temporary object. However, now instead of copying the stack, we will do very sneaky thing. We will steal the old stack from object D. So when temporary object is created, we will not make a brand new stack. In this situation, old data structure will be taken advantage of because D is about to be destroyed. So it won't need this stack, but temporary object is going to continue to live for additional nanosecond or something like that, so and it will need this stack. So it's very important in this step to tell object D, you lost your stack. It's being stolen from you, so AHT is going to become null pointer. Then in the step 2, when we are destroying the local variables, this is what memory diagram will look like. Everything else gets destroyed, however we preserve the stack. Temporary object points to the head of this stack. Now in step 3, we do the assignment. The temporary object is being assigned to the dog, and we want to do the same sneaky thing. We want to not copy the stack. So instead, we want address of the head of transactions to point to this very old stack, but in temporary object, AHT should now be null pointer, and now we are ready for quick destruction of temporary object. Now temporary object can be destroyed very fast because it doesn't need to destroy the stack. Destruction of temporary object is now quick. And now when the function fwr does its own destruction of arguments, we will end up with much faster code. The way how we create those things, so when C++ allows us to use move constructor and move assignment for steps 2 and 4. 1 and 3. Steps 1 and 3, temporary object is being created from object D. We will use move assignment so that it's a different one. Copy, move constructor, copy constructor would copy the entire stack. And move constructor will be custom made so it doesn't copy the stack. The syntax of C++ in this situation is cc account, and we put 2 ampersands. So this means not reference of reference. This means this is a signal. I am just creating move assignment. And this move assignment you cannot call for fun. Move constructor. This move constructor will be called only in step 1 during the return phase of the function. In a similar way, we will declare move assignment operator that is called only during the phase 3, the step 3 of the return procedure. Now we will implement move assignment. So it's very similar. We will now copy the code and modify only the necessary parts. So we will put 2 ampersands. This means we are making move assignment, and I'm going to call the argument mf. That stands for move from. Move constructor from, and now we will print the address to this. CNAME gets copied as we did before, and balance gets copied in the same way. However, address of the head of transactions will now just be mf. It's easier. We are now only copying the pointers. And we need to inform the object mf that it's a victim of move, so that when its destructor gets called, it doesn't destroy very valuable stack. We should put mf.aht because this is a pointer that can become null pointer. Now we want to copy the copy assignment and create a move assignment that is going to be similar to the copy assignment. How do we do that? The argument of the move assignment is move from another credit card account. We first modify every assign from becomes move from. And address of the head of the transactions will be moved from. Now we steal the address, so the stack is stolen, we are not copying the entire stack, and move from .aht becomes null pointer. We will now compile and execute the code. So the old execution, just to remind you, calls copy constructor and copy assignment. Now, when we now compile the new code, it will call move constructor and move assignment. So move constructor and move assignment are called, and we saved a lot of time by having simpler destructors. So this is the end of the video series about C++ and the introduction to object-oriented programming. We have learned what objects are, how to create basic objects, how to create copy assignments and move assignments, and now in the website you can see examples and programs that are made using this new knowledge. Okay, bye, thank you.